Okay. Section 1.3, the for statement. And section 1.3 and section 1.4 is going to be the last we're going to be talking about this temperature converter. After this, the book moves on from it and does some other stuff. So maybe there's another converter later on in the book. I'm not sure. But for now, this is the last of it. Writing it. Well, here's another way. Instead of using the while statement, which we used in previous videos, previous iterations of this temperature converter, we're now using the for statement. The for statement, how it differs from the while statement, they're very similar. In fact, the book says the difference is the word I was looking for was arbitrary. The book says gives it the difference. It describes the difference as being arbitrary. And which one you choose to use is going to be which makes most sense to use. So whichever one. They both accomplish the same task. They're both loops. They're both have test conditions, and you give the parameters, and the for statement will test those parameters as long as it falls within the statement, within its second, within the second condition. The loop will continue. The test will continue until it no longer. Until it falls out of it and then it ends. Similar to the while statement. The for statement versus the while statement. For the while statement, you're using commas to separate each argument. Right? 3 different arguments separated by 2 commas. Well, in this case, we're using, for the for statement, you got to use semicolons. And they're not described as arguments, they're just described as sections of the for statement. Again, probably an arbitrary thing, the name of what it is. Just know that they're separated by semicolons versus commas. Okay. And then after this, this is just me. I just wrote out the example. There's a couple things I want to point out with this example of the converter. First, and something the book talks about, is one thing you don't notice is a second pair of braces, or a second. Actually, finish it off. So that's one thing you don't notice from the for statement, right? Previously, with the other converters, with the while statement, we had a braces, open braces over here, and a closed brace to close it off. If you only have one set of instructions, like we do here, it's just one print line. You don't need a braces. You can just do 4 and then the 1 line. Previous examples of the temperature converter, we had multiple lines of code. This one's only 1. You don't need a braces. Same thing for for or while. One. You don't need braces, but you do need it for the main function. The for and printf doesn't. Everything's within the parentheses. Now, for statement. What else do we want to talk about? The general rule. And the book describes about what exactly kind of goes into depth about what exactly a loop, the loop is, and what the for statement is doing for each step of instructions right here. But it's pretty straightforward. The first section of this for statement is initialization, or the it's up here, initialization. That's where that came from. So this is initialization. This is the test condition, and then the test or the condition is the second part, and the third part is the increment step. The increment. That's the third part. 3 parts of that for statement. The difference for this, the way this for statement is written, if you notice, we only have one variable. We no longer have a variable for lower, upper, and step. This is not part of. This shouldn't be here. Don't pay attention to this part right here. This is part of what is a symbolic constant, which I'll go over in a second. But this, you just imagine that this part is gone, because this program would function properly with that not being there. In fact, that's not supposed to be there. These 3 lines right here are not supposed to be there. Everything that the code needs is in these 2 lines, okay? Or these 4 lines. We take all the variables out. We no longer have a Celsius instead of Celsius. Oh, the general, and that brings us to the general rule. When it is permissible, in any context where it's permissible, to use the value of a variable, okay? When it's permissible to use the value of a variable, what's a variable? A placeholder for anything. It could be any type of data. The variable can be the name of a car or a number or whatever information you're trying to store within that variable. So when it is permissible to use that value of a variable of whatever type, in this case, specifically we're talking about this right here, this f. That's a variable type, as well as this, right? Variable type. What type of variable is that? That's a data. That's an integer. What's an f? Float. Okay, and this is what the book's talking about. The general rule. In any instance where it's permissible to use the value of a variable of any given type, in this instance we're talking specifically about the float. Okay, the float indicator. Remember, this integer belongs here. This fa is pointing to this, or this percentage indicator refers to this right here, or Fahrenheit refers to that. This second integer refers to what was before Celsius. We had an integer, or we had a variable named Celsius before, right? When we were using the while statement. Well, now this is gone. It's written a little bit differently. We no longer have that variable, but because this is a float value, it's saying the general rule is as long as this section right here, which is what points to that, this is pointing to that. As long as this expression right here becomes, as long as it is a float point, which is a decimal number or a fractional number, as long as this equation or this statement, this set of instructions, as long as it results in a fractional number, you can have whatever you want right there. Doesn't matter what it is. It could be anything, as long as it's a float point number. You can use any form of that, and specifically it says any form of data. And I've used as example before too, x equals 10. Instead of using x equals 10, you can use x equals 5 plus 5, or x equals 2 times 2 plus 6. Whichever way. In the example I use would be specific for an integer. That wouldn't work for a float point because it's not a float point number. That would be a whole number. 10 is a whole number, not a float point. Float point is a decimal number. But that's not the point. That's not what I'm trying to get. That's not the point I'm trying to get across to you. As long as this results in a float point, you can use it. It's permissible in any context. Now, that is the gist of the four statements. These numbers, 0, 320. Those are kind of like quote book terms, magic numbers. It's good practice, or it's not very good practice, to kind of hide these within the code, like the way it's listed right here. It's mixed in the code with the code. Book says try to avoid doing that if you can at all possible, because when someone else comes in to read your code, it's going to be, or even you. Another example it uses is this: if you need to make an update to that code, or you need to come in to update the program, maybe our temperature converter, we want to switch it to 400 degrees instead of 300 as a max. And we don't know, and that's a bad example to use, because this temperature converter is very simple. If we had these numbers that are not going to change at lower and upper limits, and we had a lot more code, it's going to take a lot more time to go through that code and change one number, and it would be a tedious task for you to have to go through. We don't want to have to. It's more work for you. Okay, so it's saying whenever you can possible with these magic numbers, it's best to use them as symbolic constant. It's a substitution of sorts. It's almost like a variable. It's not a variable at all. Variables are completely different, but they kind of do the same thing in a sense. They not hold information. No, it's different from a variable. Different from a variable. This is saying anytime you see these three letters, and you have to use uppercase. Let me rephrase. You don't have to use uppercase. It's strongly suggested you use for the while you're handling your sheet. You're saying whenever you see these three letters, capital letters, instead of using them, use 0. Okay. Whenever you see up, replace it with 300. Every time you see STP, replace it with 20. That's all this is. This is the define octothorpe define. Right, and it has to go right here, right beneath the standard library reference information. Right under that, that's where all this stuff goes. The octothorpes go up here. Octothorpe define low space 0. Then comments. Very important. Also, you must write the comment with these, because someone comes in, they're gonna look at your code. They're gonna see if they see low 300 up 3 or low 0 up 3 like that. That's what is that? That doesn't give you much information on what exactly that is. But writing a comment, that's where you need to write a comment to let them know it's a lower limit of the table. This is the upper limit of the table, or upper limit of temperature converter. Whatever the comment you're gonna use to specify exactly what it is that you put up here. You're gonna want to put that in a comment. No semicolons. These symbolic constants, you don't use semicolons. You just octothorpe define low, and then octothorpe define, then the name of the symbolic constant, or the text that you want to, or the name is the name, and then the replacement text. And this could be anything. Symbolic constant is similar to what a variable has to be. It can be named, as long as it starts with a letter, doesn't start with a number or a special character, you can name it whatever you want. Again, uppercase, always uppercase, and that uppercase is specific. Let me rewrite it. I gotta get better at doing the spacing and like my text size, font size, text size. I always make it really fucking big or too small, or it's never right. Okay, again, capital letters, always capital. You're gonna want to use capital to easily identify the location of your symbolic constants. Okay, it's just a fast way for you to be able to see them, or someone to be able to see them. And everything else is the same. So that's what it looks like. That's what the code is going to look like, with not much in the code. The only difference is replacing the 0, the 300, the 20 with low, up, and step. Again, it's actually it makes your code actually just a little bit longer, right? 1, 2, 3, 4, 5, 6 versus 9 characters. But you're gonna get more flexibility. You're gonna save a lot of time doing it this way with the symbolic constants at the top. It's gonna save you a lot of time. It's gonna be more efficient. Your code's gonna be more efficient. It's better. It's gonna be better. So that's what it looks like. Symbolic constants. They're the space, name, space, replacement text, and then comments. No semicolon needed. Name must be in uppercase, so they are easier to find within the code. And that finishes off the section 1.5 or 1.3 and 1.4, the symbolic constants and the for statement. All right, and we actually recorded this time. 40 minutes in. I fucked up by moving the camera too much. I think we're done. That's gonna finish it off. That's gonna top off of this 15-minute frenzy. Very short. The general rule: in any context where it is permissible to use the value of a variable of some type, you can use a more complicated expression of that type.